Swayam Prabha. Digital India. Educated India.
Is an invited lecture by Professor Iqbal Mujtaba. Iqbal is a professor of computational process engineering and is associate dean at the University of Bradford. He is a member of the faculty of engineering and informatics in the Department of Chemical Engineering. He is actively involved in many research areas such as dynamic modeling, simulation, optimization, and control of batch and continuous processes. Special interests in distillation, industrial reactors, refinery processes, desalination, and wastewater treatment. His current research focus is in the area of water, energy, and food. 3 of the 4 key challenge areas for future chemical engineers are identified by IChemE. Currently an executive member of IChemE, Computer-Aided Process Engineering Subject Group, the European Committee for Computers and Chemical Engineering Education, and chair of BUT Chemical Engineering Forum Bangladesh. Is associate editor for South African Journal of Chemical Engineering, member of the editorial board for Processes, Energies, Desalination, Asia Pacific Journal of Chemical Engineering. Has published over 330 papers in engineering journals, conferences, and books. Supervised 33 PhD students since 1997 and is currently supervising 10 students. The title of the topic is Water, Water Everywhere, but not a water to drink. And we look forward to hearing that talk.
Thank you, Chairman. Good morning, everyone. So you have got the title, right? So let's see whether you agree with me or not right at the end with that. So I do not have a kind of outlines of the talk because I want to explore that with you as we go along. So purposely I deleted that. So I'm not giving you any upfront the structure of my presentation. So what I'm going to do, following the very 2 nice presentations, which are very, very relevant to my talk, and I'll be referring to those as I go along. I'll be setting the water landscape around the world and scope for the PSC community, that what we can do or what we have been doing over the last sort of 30 or 40 years. Imagine a situation, you have just attended the nature's call, you wanted to flush the toilet and there is no water in the toilet, or you had a very scary dream at night and you felt thirsty and you wanted to have a glass of water, you run down to the kitchen or wherever and there is no tap water. So how do you feel, right? But of course, the people in the Western world, many parts until now, but that's not going to be lasting very long, they cannot comprehend such situation. But in many parts of the world, that luxury is not simply there. Okay, so if you look at the United Nations Sustainable Development Goal, and you can see 17 of them. So just to look at it, you can clearly see the goal 6 is the clean water and sanitation, which the focus of this talk. But you'll see they are interlinked with many of the sustainable goals. You cannot just, keep it alone on its own, because you'll see the clean water is needed for very good sanitation. And if you don't have that, of course, that's going to impact your health and so on. So where are we in that particular aspect? So if you look at here, the 10% of the world population do not have clean water close to home, right on the left-hand side. But if you look at the right, that's the feature. In my childhood, I had to walk also almost about 500 meters to get fresh water for the drinking purpose, not for washing and others. So it's a very similar picture you will find in India, Africa, and many other places, in Bangladesh, of course. Globally, about 2 billion people use the drinking water, which is contaminated with fish. And you end up with all sorts of diseases you can find in World Health Organization website, and it's a good sort of statistical data there. What about this toilet and link to sanitation, where you need quite a bit of water? And if you don't have it, what sort of problems you can have? So on the left-hand side, if you call it a 7-star toilet, on the right-hand side, for many, many people in the world, that will be a 5-star toilet, right? But if you look at the condition there, and people going outside, of course, for attending nature's call, and there is a nice film, I'm sure the Indian, you will know that this toilet love story, right? It's all about the sanitation and having the toilet in the house. And it's a must-watch film. and I watched it a number of times. And it's a societal problem. It's showing you that if you don't have the toilet, what sort of problem you can have even in your family life. Because that lady came from the city, and that gentleman lives in the village where there is no toilet in the house. So the ladies there, they go out early in the morning or late at night to attend the nature's call, and all sorts of problems, the safety and security associated with that is very much depicted in that film. And it's very close to my heart. So if you have not watched it, it's a must watch. In YouTube, you can find it out, right? So again, looking at the Sustainable Development Goal 6 and how it is connected with 8, you will see that 3 out of 4 jobs that make up the global workforce are heavily dependent on moderately dependent on water, and so on and on. And very nicely, that has been depicted in this recent paper in Applied Energy, where you can see the water stress in the border of US-Mexico, what sort of economic problem that created and how they are trying to tackling it technically, the resolving that. So we cannot just ignore the economic growth and just ignore water, and would like to have a very good economic growth in our country or wherever we live. So these are linked again. Just a few minutes ago, the presentation was about agriculture. So if you look at the 70% of the water goes into agriculture in many parts of the world, not in the West, it gradually decreased because they have got more industrial use of water than agriculture. But however, we talk about often the biofuel and the green energy, et cetera, et cetera. But then producing biofuel, again, to produce a 1 liter of biofuel, you may need 1,000 to 4,000 liters of water, again, depending on where you are. And again, what about our food habit here? So if you look at here, chocolate, if you're loving chocolate, then you look at the consumption of 1 kilogram of chocolate will consume 17,000 of water, and goes on with the meat and rice, cotton, etc., pasta. And right at the bottom is egg. And I purposely put that egg right at the bottom, which consumes the less amount of water, because I cannot live without egg. Okay, our whole family, they like to have eggs. So I made sure that that is there. But the list is very long. It's published by the Institution of Mechanical Engineers a couple of years ago, but you can see, and you can decide, your food habit kind of thing, because that's going to impact on the consumption of water. So the increase in water demand, of course, that results in increase in water energy demand as well. We had organized workshops back in 2015 in Doha, Qatar, and in India in 2015 at IIT Gandhinagar, when I met Bab Singh at that time. And that was funded by British Council, Texas A&M University, and Indian Science and Technology Ministry. And that was held in Gandhinagar, IIT. And that book was edited by Srinivasan, myself, and Nimir Al-Bashir. Following what we had in those 2 meetings, we covered almost 50 contributed from those workshops and invited contributions from around the world, which actually captures between water, food, and energy nexus. If you look at the huge amount of water we use and the consequence that we produce a large volume of wastewater as well. And you can see the almost 300 million tons of synthetic compounds are disposed annually, and that was 2006. But it's more than that. And many of them are very harmful to our health. So the bottom pictures you can see here, right at the left, Bangladesh, where I'm originally from. Hindustan Times published that one only 26th of November here. I'm sure you're familiar with that. And right at the end here, that was a 1990 UK Blackpool beach. So the condition of the water systems or water around, you can see that how contaminated they are. And if people are drinking or using this water, the health impact, we don't have to tell. The pictures is telling, what sort of problem this can bring to human health. So looking at again, the Sustainable Development Goals 3 and 6, and looking at the good health and the sort of linked with water, you can see that what these contaminants do to our health, even the endocrine disrupting chemical there are, and the sources are agrochemicals, pharmaceutical drugs, steroids, etc., etc. And people become worried, when you have got this, your water system is contaminated water. That's 2011 in China. Suddenly people found out the government has admitted that the river water has been contaminated, and still the long queue for water to get the fresh water, because you don't want to damage your health by having those polluted water. Again, what is happening? Increasing our population, of course, is being increased gradually. If you look at the continuous line, that was the predicted line back in 2002, but it has already deviated the population. Sadia was born, she was the 7th billion child, born on 25th of October. The world has seen the 8 billion baby was born on 15th of November, just last month. And the population is growing. That curve has deviated quite a bit. And you can see the amount of water, of course, needed will increase more than what we can think. Freshwater demand is increasing by 64 billion cubic meter a year, while the world's population is roughly growing by 80 million each year. So everything is on the increase. So if we look at this one, so far what I presented here, world population is growing. Therefore, the water demand is growing, producing more wastewater and creating the health problem also. So everything is on the rise. So what can solve this problem? Water resources or the technical solution? Do we think that these two aspects are enough to tackle the problem we have against this fact of the increase in population and the increase in water demand? So let's explore together. Right, so that's the title of the talk here. We don't have any problem with water. We have got plenty of water around, right? Wastewater, plenty. We have got sea around, 71% of the Earth's surface is water. But it goes with the ancient mariner's rhyme that water, water everywhere, not any drop to drink. And you can realize that saline water is 97% of the water is saline, it's not drinkable. Over the remaining 3%, only a bit of that is a surface water. We talked about the groundwater, we talked about the recharge of the water and etc., because the rest of it is frozen and we don't want to break. And then we have got a vast volume of wastewater. We've talked about it from commercial sources, domestic use in the toilets, when we have shower or when we cook thing, all the water coming, but it cannot solve. So the answer is no. So if it is no answer, then how do we go about it? So if you look at this now, linking sustainable development goal with 13, and you have got the water is a 6, and then you have got economic growth is 8, sustainable development goal, and then zero hunger. Everybody, we want the nation to be fed by food. But look at what happened in Europe. It's just recent, this year's picture here. Spain's surface water reservoirs are at 40% capacity, gone down significantly. Yeah. Look at Italy. 70% of the Italian agriculture depends on this river Po, which actually the surface water provides for irrigation. And Italy has declared this year the state of emergency because the water level goes down. What about Germany? Serious disruption in supply chain because the water level goes down the surface because of the climate, the drought. And then that hampered, shipping, the boats and etc. So could not bring the foods or other essential. So everything, so again, look at here. The climate change is also impacting the surface water and is going to impact the irrigation, whatever we want. These are all linked. We cannot just avoid, isolate that, yes, the Sustainable Development Goal 6 is only related to the water. Everything is impacting water and our life. There's a nice contribution from UCL. Lazarus, some of you would definitely know, is actually showing where the water is coming from and where it is going. So if you look at the precipitation from the sky, it goes to the groundwater, then of course the rivers, lakes, and the ocean, and then of course through desalination, again you get the desalinated product, wastewater treatment, etc., and goes to industry, agriculture, households, etc., and then you reuse it and recollect it through wastewater treatment process, etc., etc. A nice presentation we published also a few minutes ago about to minimize the water consumption here. I'll refer to those work in few few minutes time, but that is the picture where we are. So water sources, the question was, have we got enough water source? No. Have we got the technology enough? Maybe, but is it going to solve the water problem? So if we look at the water sources, mainly surface water, seawater, and then wastewater, huge amount wastewater. Then you have the wastewater treatment process, the physiological or the physical-chemical process and biological process. Desalination can be thermal membrane, the major sort of thing. Wastewater treatment, again, physical-chemical, biological processes here. So there are some processes here, desalination, multi-stage flash, reverse osmosis, multi-effect desalination here. You have got the activated sludge process for wastewater treatment. Then you have got the advanced oxidation process, nanofiltration, etc. And there are other processes as well. I have just only put few of them as far as where the water sources and the technology we have. So question is now, are the technical solutions, which we are interested as engineers kind of thing, even most efficient? And you have seen some presentation just a few minutes ago by Babji, that is it going to solve the problem? Water problem of the world cannot be addressed by technical solution only. Why? Let's look at this, explore that. You know, in the first presentation, you have seen the Indian picture, but that's the global picture here. The blue, where the plenty of water, the red is the serious scarcity of water. And of course, you have got, you can sort of, the yellow here, Bangladesh here, India here, and the Pakistan here. You can see the overstress here. The problem is not only the availability of physical water around you, but the lack of, you know, the infrastructure, which requires money. The economy of the country will also determine the bringing the water to the people, you know. So it's not only that you can see water, but bringing to close to people or close to industry is a problem. So it's not only physical availability, but the economy also is interrupted. Let's look at here. This is CNN News, 19th of March, 2019, and look at the prediction of England here, right? The West I'm talking about here. Severe water shortage could plunge England into jaws of death in 25 years. That is the prediction, okay? And we cannot just avoid that. It's coming. What about water wars kind of thing? There's a picture 2009 in India, right? A number of people died because they were fighting for the fresh water, which is being supplied by the tank here, okay? And then what about this side of it? 220 river basins are shared between countries, right? So if you look at in the world, the Danube River, yeah, it's now quite polluted. But who is polluting? Somebody upstream, and the effect is on the people living the downstream. But who is going to manage and talk about it? It's again the political matters, isn't it? It's not a technical solution. Technical solution is very quick, but the political solution can take long. What about the problem in the Middle East, kind of Syria and other places, kind of all started with water. The background, the story were told by this gentleman at the water management conference we held in South Africa. You remember which the guy, social scientist we invited, and he was referring to the problem in the Middle East linked to the water. Right, so technical solution is not enough. Right, so when you look at the water management kind of thing, it has got many aspects of the many dimensions of it. Some of them technical, some of them social, some of them technical, social, some of them political. Of course, the sharing water resources, the political one. Togo and myself, we organized a water management workshop in 2016 at which, including South Africans, Egyptians, and UK scientists. That was a big one over 4 days. I think 69 participants. I think that was the biggest sort of thing over 4-day discussion, which we captured in that book. So if you look at is several aspects. Cost-effective production, which is the technical, of course. And then wastewater treatment is not only technical, the social problem is there. And I'll talk to you about the social problem. Efficient and cost-effective water network for distribution. You know, the Toko, Srinivasan, Grossman, and many others looking at the Mahmoud Halwagi, many others looking at that, the effective water network from the PSC community. Then again, the effective use of water in agriculture industry, the first presentation referring to agriculture. So the question was that, are you irrigating the same land with the same amount of water for different products? If it is, then it is not efficient. So that's why the precision agriculture is coming up. And of course, I have heard and I've seen on the television that Israel and India, they are quite interested in that particular aspect of precision agriculture, and which is that using big data, using drones and etc. You collect those data, and in the morning today, you have listened to artificial intelligence kind of thing. So all these big data are being analyzed to find out which crop needs which amount of water, what sort of pesticides you need. So you personalize health, you heard about in the morning. We are talking about personalized agriculture here, about giving the right amount of pesticide, right amount of water so that we don't waste water. So the precision agriculture is coming. I'm not going to talk more about it. Then, of course, the water demand management. And that's where every one of us can contribute a part of that water demand management. And we'll talk about it in a few minutes' time. Let's look at what PSC has contributed over the years, right? So in the area of cost-effective production of water, either from seawater or brackish water. So of course, we have been involved, myself and my students and co-workers. This is our recent book on desalination, published in July. And of course, the many others, you can see, look at here, from John Flower, Leeds University to Mahmoud Halwagi, this Cambridge University Specialities here, then David Bogle and Capolina from Italy, and then Marshall is here, 2008, but again, the life cycle analysis was done, which is very, very important, cost optimization, etc. So you can look at it. And some of the work again in India, if you look at Bandi Ulapuri, I think IIT Guwahati, they have been done fantastic work in that area. And then again, right up to the end, most recent work by Pistokopoulos, the status, you might know some of you, and is gone on and on. So the PSC community has been involved in many years in addressing cost-effective and sustainable production of water. On the wastewater again, myself, Srinivas and Mezozi, we have been organizing those workshops that have been captured very well in these books, our contributions here. On top of that, you will see a lot of other colleagues in the PSC are contributing here. I can see Dominic Fu here, group, Grossman down here, Halwagi, the Ali Al-Kamal here, and goes on and on. And some of course, the work you are familiar with here, Toko and Raj and Babji, you have been involved also some of the very nice work in this area. Right, so wastewater. So I told you that we can, technological solution is here. We can produce, the water from the wastewater. Are the people taking it? That's the question, right? So my 2012 experience in Singapore is that you remember that PSC took place in 2012 in Singapore, and I was invited to give a keynote on water again. And I took a taxi from the airport, and I was talking to the taxi driver, what is good about his country, and etc. He said, our prime minister is very good, but one thing we don't like about him. So what happened? What's wrong? He said he is forcing for the last 2 years, forcing us drinking our own pee, means our own urine. Okay, well, how? He said the prime minister is collecting all the wastewater from our, sort of toilets and etc., processing and bottling it and giving us back to us. So he is thinking that he's drinking his own pee, basically the prime minister forcing. So that is what the people think, right? And look at what the Londoners think. He says, it's definitely not something I would do, even though you treat it and package it. That's a look at. I think chemically treated sewer is a step too far. They're not ready. The technology is there. Then what about India? Study in Bengaluru, 2018, 28% population is not accepting that treated wastewater for drinking purpose. This is too far away. So this is the social problem, isn't it? It's not a technical problem. Technical solution is here, but whether it's socially acceptable or not, that is the question. So we have to work with a lot of people around us. It's not only systems engineering people. Okay, networking, where many of us are involved. Of course, these two guys I can see here have been doing fantastic job. So networking here is got two aspects of it. The one is the water targeting. You find out that how much water you need. And then of course you design the network to distribute the water allocation. And the nice presentation just a few minutes ago about this intentional waiting exactly to allocate the resources at the right time so that you can minimize the wastewater or the water, fresh water consumption, right? So a number of colleagues from the PSC community, they have been working in that. And of course, the two popular terms they commonly use, source and the sink, right? So there's very common terminology for this group of colleagues. This is again one of the examples from Qatar, eco-industrial plants. You can see there are some centralized water treatment plant, the wastewater treatment. Some of them are decentralized within their own plant, but they have got the integration of using the water resources between the plants around them. It's not only limited within the team. It's a nice optimization problem solved by the PSC community, and which of course more and more probably we'll see in the first presentation. There was an assumption that water being charged in a neighboring district or whatever has not been considered, or whatever, or the sharing of the recharged groundwater, something like that. So concept is very similar, although the example was for agriculture, but in industrial setting, it is happening. So maybe in agricultural setting is a possibility, right? And again, if you look at the network synthesis work by colleagues here, the first one, again, Nilesha, the Imperial College Group, Cheng Kor, there, looking at the water network synthesis again, source and sink, I mentioned there's a very common terminology for that sort of work. Dominic Fu's group, again, looking at the structural based model for water network synthesis, 2021. And then on that side, again, although it's about 7 years old, but it's a very nice review of the water network synthesis work. It's captured very well in that paper. So water demand management, the water psychology. So we are bringing out psychologists into the picture now. We talked about technology. So water demand management has got two aspects. One is the efficiency behavior. One is the curtailment behavior. So efficiency behaviors, a number of PSC community, our colleagues, they have been working in the efficiency behaviors to reduce the amount of fresh water. It just, Babji given a very nice presentation a few minutes ago about this water minimization. That's the efficiency of the process. You look at it from the water use point of view. But the curtailment behavior, which are individual, right? Are you running the water tap while you're brushing your teeth? So how many liters you are wasting? That's the question. What about the washing your clothes in the washing machine? Is the half load or full load? How much water is going on? This on us. Are you going to have a 10-minute shower, wasting or requiring 90 liters of water, or the 5 minutes will do, which can reduce just 50% of our water. 5 minutes quick shower, about 40-45 liters of water. Or having a luxury bath, 190 liters of water there and you enjoy, kind of thing. Forgetting about the world where I've mentioned 2 billion people do not have even the clean water to drink or anything, right? And they're dying. So these choices are ours, all of us here. Even every one of us, every day we can save 1 liter of water. You think about it, 365 liters of water. And if we multiply by 30 or 35 people, think about it. That will make a drop, even will contribute to that saving. So that's us. On the efficiency behavior, you already had a presentation latest few minutes ago, but there are people. This is again a dairy industry, cleaning. Babji was looking at the cleaning, and India, I think the biggest consumer of water, right, in the milk industry, I believe, because of the cleaning and etc. And I have seen your work, including Toko, your collaborative work in that one on the dairy industries kind of thing, saving a lot of water. But not only that, you are trying to recover valuable materials also at some point when I was in India, that because a lot of protein goes with the wastewater of milk industry, right? So that's again a scope there. So this is a work again in the dairy industry, again, trying to minimize the cost, but we've got a utility cost where the water cost is involved. So you can look at it. This again by Grossman and co-workers there back in some times, but looking at the water synthesis network here, they could optimize the water network, and that would yield 1.54 gallon water per gallon of ethanol they're making. At that time, that was the lowest, but I'm sure that it has been improved quite a lot, and many other examples are there. This is an UK industry, and that was presented in 2016 in the Water Management Conference, and subsequently it was published. It's based on water cascade analysis of industry this gentleman was working in, and through the reuse of some of the contaminated water at different parts of the process, you know, they were able to reduce 50% fresh water use, and they could reduce the wastewater going into the drain by 50% as well. It's a simple technique, water cascade. I think it started with Robin Smith kind of thing, the water pinch back in those days. Very simple application, but it still could make some benefit. Right. So preliminary summary, what we have had here is not only technical problem, technical solutions. It's much more than that, and we need to work together, to be honest. Right, so the water grant challenge, if you look at the people here who have been contributing, when it comes to water production, PSC is contributing quite a bit. Wastewater treatment, PSC again contributing quite a bit. Network and distribution, again, PSC community is doing quite a bit. Precision agriculture, there is a scope here for PSC based on artificial neural network, big data science, etc., based on ops. But you can see the other people who are there. You know, the forensic scientists, public health, the lawyers, the psychologists, policy makers, and etc. I know that in India, majority of the industry now, zero discharge policy kind of thing in place, but it has come from the government, isn't it? So people are implementing those. Our own work in desalination kind of things, you can see we have got quite a bit of collaboration around the world, and in different desalination processes, we have been working with Italy, Jordan, China, Libya, and Iraq as well. On the wastewater treatment, again, we have got some collaboration with Iraq as well. We have published that book recently on wastewater treatment by reverse osmosis process. And again, if you look at the global challenge, and I've showed that how the sustainable development goals are all linked with water, many of them, to be honest. So water, food, energy, health, and well-being, they're all interlinked. And I have mentioned to you our work with Raj and Toko, what we have been doing in the past, you know, putting those in the public domain, some of the contributions made there, and of course, many more are coming. So challenges and sort of for the PSC community, I've got 2 or 3 more slides, if you bear with me for a couple of minutes. So the challenge is huge, because if you look at a smart city concept, right? So in a smart city, you will need all this. You have got houses, you have got industries, you have got education, you have got hospitals, agriculture, etc., etc. And of course, the water management I have discussed, there have got many aspects of water management you have to take care of, including agriculture and demand management, etc. And people have been using many sort of tools, right? From the drone, robots, measurements, sensors, big data, artificial intelligence, etc., etc. I organized that workshop in 2019. Before that, I did not have any idea that how contaminated the hospital water is. I did not have any clue. I thought it's a normal sewage like we have got in houses. And hospital wastewater is the most contaminated and most difficult water to be treated. That's what I have been told by the biomedical scientists working with hospital wastewater, because the measuring even the trace amounts of contaminants in hospital wastewater is difficult. And people have been working like polymer chemists. They have been trying to develop sensors for them. So if we have to solve this problem of a smart city, supplying water for everybody, it's a big, big problem, right? And we are not near there, because it's not only problem formulation, the algorithms goes behind it, and the solution and the acceptability of it is all are in question. So in our recent paper this year, led by Professor Ghani, we have just highlighted that what is a possibility of doing in future for PSC community, and I will finish with that one. So if you look at, I have extended that what we presented early in this year. So that's the problem just around water. So if you look at energy sources. You can have all sorts of energy sources, including biofuel, the thermofuel, the solid waste fuel, and etc. You have got the technology for the seawater processing, many of them are put on there. Then you need a different grades of water. You don't need to have the agricultural water same as our domestic water kind of thing. The hospital water can be quite different. So you can have a different grades of water for different uses. After use, you produce huge amount of water. You don't throw it away because then it will contaminate the river stream and surface water stream. So you have got all these technical processes here to reprocess them. And then of course that needs energy that goes in here. Down here, what you have seen this morning, 2 presentations, they are also focusing here because they are trying to minimize using the intelligent and the smart network, water synthesis network people that who are working. They're actually trying to do quite a bit of that around this. For example, the food processing, the dairy industry, and et cetera, et cetera. They are trying to minimize the freshwater demand, which is actually coming from here, right? And they are trying to also minimize the wastewater. So they're already here built in, the work is here. So if you look at the total problem here, and then you need to use chemicals going in, need raw material, and then of course the disposal, again, the CO2 emission, the brine disposal, post-water, the wastewater finally goes into the surface water and et cetera, et cetera. So the problem is huge. I tried to capture all in one go. Solving this problem will be a great challenge, doable, may need to take some time, but I'm sure even starting with a very simple model, somebody can build up this one, and that would be fantastic in connecting the wastewater processing and the freshwater treatment. We, Pistogopoulos, about 2 years ago, did something, considered different grades of energy, but only reverse osmosis process here, not all the technical processes here. To some extent, they solved some problem there. We have done some smart city work using hybrid sort of distillation-based and reverse osmosis-based sort of process there. And again, we have been doing some work with Malaysia. We looked at most recently the use of the battery with solar panel kind of thing, battery storage and supplying water, the fresh water. We are doing some experimental work in Egypt here. Again, experimenting, actually trying to optimize the design of the process here by doing the experiment. Long way to go, but I'm sure PSC community is capable of providing a good technical solution for a smart city, and let the politicians, the social scientists and others work on their part, and together we can resolve the water problem of the world. Thank you.
Thank you for that inspiring talk. We can take some quick questions.
Just quick one on the network, just to understand how we really can realize it. I mean, we can rationalize it, because in order to integrate all these sources, all these ways is really a big challenge, because we'll be licensing differently with the different industry, so different entity. Just to understand, I mean, from your perspective.
Yes, so that's why I put a smart city concept that, you know, you heard about Silicon Valley, you heard about many other things, you heard about Tata Nagor kind of thing. But we're talking about, you want to create a very smart city somewhere in India or somewhere in Malaysia or somewhere here. What are the things people need from schools, hospitals, everything, the industry, the local I'm talking about, and you start with that one. But otherwise, if you do it's a nationwide, India is a very big country, right? And China is again another very, how you're going to do it? If you want to do it for whole China, then integrated process is not going to work, because the problems are different. And we heard in the morning also the irrigation, you know, the stress analysis they're doing, even though the equation is there, the stress analysis will not be the same as even everywhere in India. It will be different in different parts of India, and you apply the same equation in another country, it will be different. So that's why I started with the smart city concept, that you solve this problem within an envelope where you will have all sorts of things there, the people, agriculture, hospital, industry, and you do it that way, and then you can expand. It's not easy.
Yeah. All right, thanks.
Yes, sir.
The number that you came very close to, but you did not really pin it down. I haven't heard this number anywhere. I mean, in South Africa, for example, we are sitting at about 165 to 175 liters per person per day. What would you cite as the optimum per capita water use?
Optimum?
Per capita.
Oh,
water.
Right.
Yeah.
Well, I've seen many researches for different countries, so it varies considerably. It all depends on not only the country, but the weather also. For example, if you live in a winter country, right, people would not do shower every day, right? So people would do shower alternative day kind of thing. And if you look at a very hot country, people may want to do shower if they can afford twice a day. So the per capita kind of thing, the optimum has to be localized kind of thing, depending on the weather condition.
What would be the best way of getting to the country?
Well, also so think what I have mentioned, that our own curtailment behavior can impact to reduce a amount of water, to optimize it, to start with the personal level of water consumption. Right. And that may be the starting point to do any kind of analysis further. But I'm sure the optimum for me can be different than you as well. Not you personally, because I said whether you are used to 5-minute shower or me used to 10-minute shower, it will make a big difference.
There's one more question.
Yeah, I have a question concerning the energy water nexus, because wastewater is also carrying an energy source, which is the biomass that we produce. It means that it is also distributing, at least in what I see in Switzerland, for example, we have also a huge potential in recovering heat from the water that we use, right? And as a heat source for heating. So it means that we have to have a clear water energy waste approach if we want to reach if there is one optimum. Right?
Yeah. No, you're right. I mean, in some countries, the people are using, I think the Switzerland was mentioned by a PhD student recently I was interviewing, that probably use quite a bit of ground heat as well for heating and cooling because of the temperature difference, winter and summer, the ambient temperature and the ground heat. And that concept is now being sort of tried in Egypt and many other places, hot countries. So that's one. And when you mentioned about the wastewater sources can be a source of sort of valuable materials, we have been working for the last 2 years with a local company which treats the wastewater, but they end up with a huge amount of sludge, right? And that sludge we have been analyzed in the lab, and we have been quite successful to recover valuable chemicals from there, number one, and then the materials, the composite material for building construction. And we are very successful because we have recently been sort of awarded with an industrial fellowship to look into it even further. So yes, I agree fully. That picture which I've shown is not complete.
Yeah, but I think it's really important to have this holistic approach, because
absolutely
you can also recover the fertilizers to reproduce.
Definitely, yeah. I mean, we have recovered almost about 5 chemicals from the sludge we collected from different parts of the UK, the wastewater the sludge. 5 valuable chemicals, and at the end, the composite materials.
Very last quick question.
Thanks for an interesting lecture. But India, like countries, one side, one part of the time we are wasting water, other part they are having a water scarcity. It is happening in a phased manner. Okay, so one way they are addressing like linking of river and other issues.
Yeah.
Is there any technical solution on that particular aspect?
Well, the solution you are talking about, that's why I mentioned the political, like the political will, and sometimes the things have to come top down. Sometimes you can do bottom-up approach. For example, the reducing the consumption of our own water. This is a bottom-up approach here, we can all control. But sometimes it has to come from the top, because we were talking to some of the civil engineering colleagues at IIT Madras here, and we noted that in many industries now, the discharge of liquid is not allowed. So they have to process it within the plant before. So it's a zero liquid dishes, ZLD policy kind of thing. So some of the policy has to come from the top, that how you share and how you distribute. I don't know, technical, maybe the locals, they may be able to tell the technical difficulties of solving this sort of problem.
We'll discuss it.
Okay.
Thank you. Thanks, Dr. Mustafa, for the very interesting and inspiring talk. And we'll conclude this session and hand it over to the next. And thanks again to all of you for participating and making this lively and interactive session. Thanks a lot.